voltage-shunt feedback amplifier. Okay, so let me draw the circuit. This is a circuit of voltage-shunt feedback amplifier. Okay, so first we'll identify what is the feedback element here. Okay, see here, this is the output side and this is the input. Okay, yes, so this is a collector we are taking output. This resistor R dash is connecting the output and input. Okay, so what is R dash? Now R dash is acting as feedback element. Okay, it is connecting the output and input. Okay, so now this is your feedback element. Now we'll see about the sampling and mixing, voltage sampling and shunt mixing. Okay, so how to know whether the circuit consists of voltage sampling or current sampling? Suppose if it is voltage sampling, yes, V naught is equal to 0 makes the feedback is equal to 0. Okay, yes, V naught is equal to 0 means just you make it ground, means make it 0. Okay, so to find whether that feedback is becoming 0 or not, yes, see here, yes, assume that through R dash, yes, a current IF is flowing like this. Okay, yes, R dash is connected between this and this, these 2 points. Okay, it is connected between this point and this point. Fine. Feedback is actually from output to input, but as it is negative, the direction is like this. Okay, yes, this is the node. So from this node, assume that a current IF is flowing. Okay, so now what is IF? IF is equal to, yes, here what are you going to have? VI, and this is V naught. So what is IF? Potential difference divided by the resistance R dash. Fine. Yes, VI and V naught. VI is very small because it is the amplifier circuit. VI is very small. V naught is very high. So it is approximately equal to minus V naught by R dash. Okay. So now making V naught is equal to 0 is making the feedback current is equal to 0. Okay. Yes, definitely you can take only the current because all these are nodes. Fine. So as V naught is equal to 0 is making the feedback is equal to 0. Hence this sampling is voltage sampling. Fine. Yes, how it is shunt mixing? Yes, see here, this current is mixing in shunt. Yes, because here we got one node. Yes, node means there exists current division. Okay, so as the feedback is added to the external signal in shunt as current, then this mixing is called shunt mixing. Okay, suppose if you convert this Vs Rs using source transformation, if you convert Vs Rs into Is Rs, then Is here and Rs parallel, then addition with that the current If is added at this node. Hence, yes, this is said to be shunt mixing. Okay, so totally it is voltage sampling and shunt mixing. Then what is the next step? Yes, you must find the input and output circuit. Okay, to find the input circuit, what we have to do? Yes, because it is voltage sampling, make V naught is equal to 0. If V naught is equal to 0, yes, then this R dash other end seems to be connected at 0, means grounded. Okay, means R dash one end is at this base point, this node, and other end is connected to ground. Okay, so yes, how to draw this? Yes, the input circuit is, see here, and it is grounded. Yes, because output voltage is 0. Yes, as you are finding only input circuit. Okay, don't think about output. Yes, here you have Rs and here you have Vs. Fine. Yes, at this point you are going to have your R dash. Because V naught is equal to 0 makes this node connected to 0. Yes, then R dash seems to be connected between this and ground. This is all ground portion. So that is the reason instead of taking ground here, just I am taking this R dash and making the ground here. So that is the reason you got R dash here. Okay, so this is your input circuit. Then how to find the output circuit? Yes. What do you have to do to find the output circuit? Yes, to find the output circuit, you have to make Vi is equal to 0. because it is shunt mixing. If Vi is 0, means what you have to do, you have to just make it short. Then Vi becomes 0. So if it is shorted, all this is grounded, then Rs other end is grounded, then your R dash seems to be grounded. Fine. So now R dash seems to be connected between this collector and ground. Okay, so how to draw it is simply, yes. Another point, for the next circle we are going to draw H parameter model. You know it very well. To draw the H parameter model, you must first draw the AC equivalent. To get that AC equivalent circuit, you have to make VCC is equal to 0. VCC is equal to 0 makes RC between the collector and ground. Okay, RC is connected between the collector and ground if VCC is 0. Okay, so now totally, yes, at collector you have RC that is grounded because for AC analysis you have to make VCC is equal to 0. And at collector you have R dash which is connected to the ground. So totally, say this, you have first R dash and then RC. All these are grounded. As this is output circuit, don't think about your input. Fine. So this is the input circuit and this is the output circuit. Now what you have to do? You have to club these two. So now we'll draw input and output circuit. To draw the input output circuit, you have to club these two. Fine. Okay, I am drawing this input output circuit. Yes, at the base. Yes. This is R dash and this is RC. Yes, this is your input output circuit. In the next term, you have to draw the H parameter model equivalent for this input output circuit. Just to draw the H parameter model, you have to do only simple things. Just replace this transistor with its approximate H parameter model. Okay. So now I am drawing it. H parameter model equivalent circuit. Okay. First here is the base, emitter and collector. Fine. Yeah, between base and emitter, you are going to have HIE. Between collector and emitter, you are going to have HFE, IB. Yes, this is up to the transistor. The external circuit is same. Between base and emitter, you have this R dash. Yes, you have another resistor, RS. Okay. Yes, here at collector you have the resistor R dash and the resistor IC. Fine. Yes, the emitter is grounded. So this is the H parameter equivalent circuit for this circuit. Simply replace the transistor with its approximate H parameter model. Fine. So now from this circuit you have to find A, beta, Ri, R0, etc. Okay. See here, it is like a shunt circuit. So now we are going to apply source transformation for this Vs and Rs. If you apply source transformation, then the circuit becomes Is. Yes, you just draw like this, Is in parallel with Rs. Fine? Okay. So this is about your input circuit. Now we'll indicate all the resistances. Fine? This is Ri and this is R naught, and the total is R naught dash, which is R naught in parallel with RC dash, where RC dash is R dash in parallel with RC. Fine. Next. Okay. Yes, next what you have to do? You have to find. Yes, let me indicate the currents here. IB, and this is IC. Fine. And opposite to this, take it I naught. Is nothing but your minus IC. Fine. Okay then. Then we'll find first. This is voltage shunt feedback amplifier. Yes, output is voltage, input is current. So, what is the gain factor? The gain factor for voltage shunt feedback amplifier is trans resistance. Okay. Open loop, trans conductance. Yes, Rm is equal to, yes, output is voltage, so V0 divided by input is current, so Is. Fine? It's okay. What is V0? See here? Yes, you must take this parallel combination as RC dash. So what is V0? This is your V0. So you can write V0 as, yes, minus IC means I0 into RC dash, because this parallel combination is RC dash divided by Is. Is it okay? Yes, this is totally minus IC by Is into RC dash. Yes, we can write it as minus IC by, yes, IC divided by IB. I'm writing IB. Then IB by IS. So these two gets cancelled. I'll get minus IC by IS only into RC dash. Fine. What is IC by IB? Anywhere, in any concept, IC by IB is nothing but HFE, because IC is equal to beta IB. The other name for beta is HFE. So it is minus HFE into IB by IS into RC dash. Fine. Then how to find this IB by IS? How to find IB by IS? Okay. Then see this input circuit. Yes, I am drawing the input circuit once. So this is the base. From this base, you have HIE. That side you have HIE. And this side you have this parallel combination. Okay, let be R. R is RS in parallel with R dash. So totally take this as R. The total current here is your IS. Fine. From the base, the current is IB. Yes, now, what is happening here? Your IS is coming to this node, and then it gets divided into two parts. This branch current is your IB. So, how to write IB? IB equal to total current IS into, yes, the opposite resistance R by total means the sum of two resistances. It implies IB by IS is equal to R by R plus HIE. Okay, so here we got this IB by IS. So totally, what is RM? RM is minus HFE into R by R plus HIE, means in the place of IB by IS, write this R by R plus HIE into RC dash. Fine? Yes, next. So, we got this open loop transconductance. Then we have to go for feedback factor. Feedback factor. Yes, the feedback factor beta. Yes, you have to find beta. Okay. Starting, we got one expression for IF. IF is equal to minus V0 by R dash. Fine. What is beta here? Beta is feedback network output by feedback network input. What is the feedback network output? Means the feedback resistor R dash output is IF. Okay. And feedback input is voltage, output voltage. So it is IF by V0. So it is minus 1 by R dash. Minus 1 by R dash. Okay. Yes, next. You must go for Ri. Ri. See here Ri. Yes, you can write it as R in parallel with Hi. Fine. Then R0. Since this is R0, at collector you don't have any resistor, so R0 becomes infinite. Okay. So now, yes, we've got all the required things. Then we have to go for the desensitivity D 1 plus Rm beta. Okay. Then what is RIF? Input resistance with the feedback. Because it is shunt mixer, with the shunt mixer, input impedance decreases. Okay, so it becomes Ri by D. Yes. Next, what is R0F? R0F is, it is voltage sampling. With the voltage sampling, output impedance decreases. So it is again R0 by D. Fine. So then, what is R0? R0 is infinite, so R0F is also infinite. Okay, so this is about the analysis of voltage shunt feedback amplifier. Okay, yes, we have to draw the input-output circuit by following the method of analysis of feedback, practical feedback circuits concept. Then write your H parameter model, then find all these things according to the steps given in the previous videos. Okay. So I think you all understood this. Okay. Thank you very much. Thank you for watching this video. If you like this video, please don't forget to like, share and subscribe.